Hi everyone, Mr. Thrive and Survive. This is a finalization, I hope, of the last video I did concerning density. And the title of the video, I believe, was Blowing Gravity Literally Out of the Water. The purpose of the video, and the entire purpose only, was to show that gravity has fallacies to it. It has at least one working aspect, or one aspect that doesn't work, I should say. And that is density does not work correctly with the model of gravity. Okay, and what we're going to see is I talked about gravity having magic properties, and that's why people want to stick with gravity. And as you're going to see here in some of the comments, and the comments are necessary, guys, I'm not here to put anybody down, but it is to show that people are so locked into a belief system, and this is why science has become a religion, that they can't see what you are plainly showing them. There is absolutely nothing wrong with the physics, the science, whatever you want to say, with the video I did last time. And I'm going to show that, and I'm going to give you the arguments they have where they're going to say it is wrong. And this is necessary. And hopefully this will help some people who are on the fence, who are at least willing to say maybe my ingrained beliefs of what I've been taught my whole life might be wrong. Here's an example of the magic of gravity, other than you not knowing you're standing on the side of a ball or on top or upside down. One of the other magic aspects of gravity is this, that if a plane takes off and has a very slight upward tilt, the nose to the rear of the plane, it will keep climbing, correct? Yes. And if it has a slight tilt downward, it will constantly move downward until it reaches the earth. And if it flies perfectly level, okay, it should remain perfectly level. Now that is all assuming that the ground underneath of you is not moving away at 8 inches per mile squared. So one of the magic aspects of gravity is that even though the plane is flying perfectly parallel with the ground, it does not gain in altitude as the ground below you moves away. Somehow gravity magically keeps you at the same altitude. Let's say you're 10,000 feet, you are perfectly level with the ground under you, okay, and you continue to move on a ball, you would necessarily continue to move farther and farther away from the surface of the earth. However, that is explained away that gravity somehow holds you there. Okay, which defies all kind of real logic when you get into it. And by the way, there is, I believe it's on Jeranism channel, a pilot who is not ingrained into the system. He's got his own business. He is going to do his own flights and things like that to see if he can prove if the earth is round or flat. On the Facebook channel I originally had, it's probably still up there, we had a world-known physicist who was on our side. He was also retired. Before they retire, they don't like to talk too much. And by the way, I do have a copy of the principle, and as soon as I can get permission from the producers, I will be talking about that and showing the scientists who firmly believe that the Earth is the center of the universe. So anyway, there are a lot of people on our side, guys. It's growing. 2 or 3 years from now, I swear, I believe that the people on the other side will be the ones laughed at because there's no proof for their side. Let's take a look at the first person. Okay, this person calls him a troll. I'll let you make that decision. I'm not going to call him that. Gravity is a measurable force accelerating objects with constant 9.81 meters per second squared, even in the vacuum. Well, I do agree that if you drop an object and in a vacuum, I've never done it, but I'll take the word for it for now, that it would fall at 9.8 meters per second squared. Even in a vacuum. Maybe it's a little slow, maybe it's a little faster. I don't know. I've never seen it tested. But I will assume that's correct. I have no argument with that. The argument I have with the statement is gravity is a measurable force. What we should put here is some force, some question mark force is a measurable force accelerating. Here's the thing I described in the video, isn't it, guys? People will use mathematics to try to prove something. Mathematics can only describe something. Objects falling in a vacuum at 9.8 meters per second squared is describing what happens if, let's say, you drop a hammer in a vacuum. How fast will it fall to the earth? Saying it is gravity is the mistake. It's not proved that it's gravity. And because density, among other things, okay, does not work with gravity, that makes gravity an invalid force. There's got to be something better that explains that. And I will eventually get there. But the mindset has to be changed. It has to be open to understand that saying gravity equals to this, or this is what this, perfectly describes gravity, is wrong. Okay? All this stuff about the gravity and electrical repulsion and attraction has nothing to do with anything we talked about. Okay? I disagree with this one. There's no way a pressure gradient can build up without an external force applied. Really? I think you would have all the meteorologists in the world who have ever seen a 100 millibar to 1000 millibar chart ever thrown in front of their face would tell you that pressure gradients can build up without an external force. Now, it depends on what you mean by external force. Maybe my definition is different. Are you saying that there's a dome above the Earth and that's pressing down? That could be. That actually could be an answer. All right. Now, the reason why the atmosphere presses down, and in all directions, by the way, but down more than sideways, and there's a reason for that, is because the molecules accumulate up one upon the other. The way they do that, and the reason they do that, is because of differences in temperature. If there were no differences in temperature, all the atmosphere would do just like water. It would seek level. Okay, actually the atmosphere does the same thing, but it wouldn't heap up like it does. It would be flatter. All right, but because it does heap up, because of differences in temperature, the colder air being at the surface, the warmer air moving aloft, those molecules are stacked one on top of the other, and they do increase that in force. The more molecules you have stacked up, the higher the force. It's called high pressure. I don't know why people miss that from even the charts I showed. Okay, and so density cannot be the reason for an object going up or down. I will disagree with that, and I'm going to show you this on a first grade level, and we'll finish this whole thing right here. Okay, all the rest of this means nothing. Okay, constant does not explain the constant downward acceleration for all objects when in air, friction, and viscosity are taken into account. Okay, fine. I have no argument with that. That's not what I was talking about. I was talking about fluids. Air is a fluid. And why rivers on the earth flow downhill. And I'm going to show you how they would flow uphill very easily. Very easily. Now, if you want to stay in denial, fine, you won't see it. Atmospheric pressure is from all directions, all sides. How could it be? You say that if atmospheric pressure were greater, some of the water would be pushed onto the land. That is absolutely correct. And you do not understand why boats or balloons float. I perfectly understand why boats or balloons float. I even explained it. Atmospheric pressure is why water flows downhill. I must say, though, I like the video, and then he goes on to say it was a comedy, and that's why he watched the whole thing, and this person too. Guys, when the comments get more and more hateful and crazy, I mean, things that just don't make sense, you know you're making points they don't want to have made. And that is very understood by me. You know, when I post a 46-minute video, and after I finish putting the right thumbnail in and things like that, and I refresh it to make sure everything looks right, that'll be like 2 minutes after it's actually going live. There'll be like 17 views and 7 thumbs down. They don't realize they're actually helping YouTube drive people to me by that. The more controversy, the more people come. So thanks, guys. You're not hurting me. I don't care if it's 1 thumbs up and 1,000,000 thumbs down. It doesn't matter. If one person gets it, it has nothing to do with popularity. Saying you don't understand the difference between gravity and density is like saying you don't understand the difference between blue and shade. Did I say I didn't understand the difference between gravity and density? I thoroughly understand density. And gravity is not the force we should be talking about. It has nothing to do with understanding the difference between them. Wow, it's just amazing how clear you can try to be. You know, I could have said all I did in 10 minutes, but I took 49 minutes or whatever long it was, so I thought it was at a low enough level to even people who've never understood anything about density would get it. But see, they're so stuck, guys, on this, the magic, that they can't even entertain that something might actually work differently than what gravity says it should, okay? All right, only 30 seconds in. Are you really this stupid, or do you think your subscribers are this stupid? Yeah, he watched the whole video too. Here's an interesting one. The pressure is formed by whatever force attracts mass to each other. Really? Think about that statement. The buoyancy is caused by whatever force it is that acts against that force, gravity. Again, you're assuming gravity. Could it be something else, some other force not described by the word gravity? Also, buoyancy worked just fine on a spherical shape. Who said it wouldn't? Density has a major issue. What causes density to push down in the first place? Again, did you not get, I went back to it I think 3 times, the boxes that showed molecules and how many molecules per square inch it was, or how many molecules. I didn't even get that deep. How many molecules were contained in a certain size box? Okay? Pressure is formed by whatever force attracts mass to each other. BS. That's just a total made up, makes no sense. Okay? Mass is not attracted to each other. It just isn't. You could take 2 of those 140,000-ton aircraft carriers, put them 1/8 of an inch apart, and there's going to be no more attraction for them to pull each other together than if it was 2 little nickels sitting 1/8 of an inch apart. No 2 things attract to each other in mass unless there's a chemical or other type of attraction. Magnetic, for example. You do have magnetic attractions. That's been demonstrated. 2 masses have never, as far as I know, been demonstrated to want to attract one another just because they are a mass. Again, you might have chemical forces in some cases, but you can have a 10,000-mile boulder sitting next to a 10,000-mile boulder, and nothing is going to want to attract to those boulders just because of their size. That's a fallacy of the magic of gravity. And guys, I'm going through this because this explains well the fallacy, these comments. And this is why they can't move off of their science, their religion. If you weren't into the religion, you would get this. It was very easy, and I'm going to make it even easier in a second. Now, I'd like everybody's opinion. How would you interpret this? Maybe I interpret it wrong, really. This guy writes, microscopic nuclei? Water gets into the atmosphere because of evaporation. Now, and water flows downhill because of topography. And I'm going to show you how that's wrong. Let's go back to this one. How would you interpret that? I would interpret that as him saying microscopic nuclei, okay, because I talked about that. He says that I'm saying that evaporation is caused by microscopic nuclei. Please watch the video. I said microscopic nuclei is necessary for the formation of clouds. And microscopic nuclei is almost always, not always, but almost always present in the atmosphere where you are. You know what else is necessary for clouds? A cooling process. That's 2 things right there. There are more. Okay? Look them up. What is necessary for cloud formation? One of them is microscopic nuclei. A small piece of sand or dust in the upper atmosphere, or 500 feet above the ground. Okay? If water evaporates and cools and meets all the other conditions, it will condense into a cloud. Without microscopic nuclei, I don't care if it's got the 3 other conditions with it, it will not form a cloud. Okay? So, I took that to mean he's saying that I said that microscopic nuclei caused evaporation. No, that's not what causes evaporation. I didn't even get into the cause of evaporation. Anyway, I said you may want to modify your comment because it shows great ignorance. It does. Microscopic nuclei, as I exactly stated, needs to be present for cloud formation, not for evaporation. What would happen to evaporation? Then I asked him a question. What would happen to evaporation if air pressure is doubled? But if it is halved? How does evaporation happen in the first place? What causes it? I'm trying to get him to understand the process. And then he comes back with, why are you asking me a question? Well, it's because you asked me one. And a lot of people are taught best by questions. Let's get into this now. Okay, hopefully we can wrap this up pretty quickly here to further make the point one more time, what I'm trying to get at. Earth, we're going to call that the container, whatever the shape. Somebody wants to argue that I will give you the fact that no matter what the shape of the Earth, okay, all this stuff would pretty much work the same. You would have some differences when you add in topography, but let's just, I don't even know why that was even brought up. So we're going to say Earth is the container. Remember we showed in the last video water in a tube and different things like that. All right. Now, one thing I want to say before I get into this is if I take this atmospheric air pressure and I keep pushing it down on the water, the surface of the water, water, by the way, cannot be compressed. Air can. So if I keep increasing the pressure on water, it will overflow onto the land. Okay? The force of the atmosphere, if it was increased all over the Earth, would force water onto the land. It is what is most likely responsible for the micro tides, which don't even have anything to do with the moon at all, in Great Lakes and different things like that, where they say there's an 1/8 of an inch difference that they can measure sometimes. That is probably difference in the air pressure, especially in a place like the Great Lakes, where they have great changes in high and low pressure in the winter. And I believe some scientists should go out there and try to measure that. I don't know how you measure exactly how much the tides change in a lake, but supposedly somebody can do it down to an 1/8 of an inch. In any case, if you take away the atmosphere, at first the water would, well, let's just get to the end. What would happen is the water would actually evaporate off. It would actually boil off. Okay? The higher the atmospheric pressure, the more temperature is needed to boil water. Many who live at higher altitudes know this. Their cooking instructions are different. When they are at higher altitudes, they have to cook things longer. Especially if they're boiling water and things like that. Why? Because water will boil at a lower temperature when the air pressure is lower up on a mountain, for example. The air pressure is lower. It's not as compressed as what it is at the surface. Again, it compresses and moves downward on the Earth because the molecules are heaped up one upon another. And the reason why they do that, instead of just spreading left and right laterally right above water, is because of the difference in temperature. And it's that simple, guys. There is nothing wrong with the physics, I'm telling you here. You take away atmospheric pressure, water boils at a lower temperature. If you increase pressure on water, it will boil at a lower temperature. This is why NASA recently has been changing what they say is the air pressure on Mars. Suddenly, out of nowhere, Mars somehow is increasing its air pressure. Do you know why? Because they finally figured out some physicist is going to come along and say, wait a minute, they're claiming there's water or ice on Mars when the atmospheric pressure is too low for that. It should be boiling off. So my argument was, and let's go through this. Earth is the container. That's the brown part. Okay. It is not a fluid. That's why it's the container. If it was a fluid, it would be another fluid. Okay. If it was milk, remember we talked about milk or honey, then the Earth would be under that. The honey would be under the water. Isn't that how it would eventually settle out? Yes. Then you have water, then you have the air. Greater density to lesser density. As you go up, the air pressure decreases. And space is above that. And I'm going to say properties are unknown because I don't believe anything's ever been up there to honestly tell us what's there. And if it has, I don't believe NASA to give us an honest report. So I'm just going to say space, properties unknown. Is there a force pushing down to keep the atmospheric pressure higher? Well, that's something to discuss in another video. Doesn't matter with what we're going to talk about here. Now, here's the first grade stuff. Let's see if we can get it. We're assuming now that air is less dense than water. Air is less dense than water. And I'm not even going to get into that because I'll get comments on it. Anyway, here we have a hill or a mountain, okay, on the earth. And we introduce a bubble on the bottom of the ocean. Okay, a bubble of air. See how it's same color? Okay. What will happen to that bubble of air? Will it stay there? Well, if it has something above it that perfectly traps it, yeah, it will. But let's just say in nature it's open. Okay? That bubble, well, what happens? It will rise up, okay, until it gets into the atmosphere. All right? It will, because the density of water is greater than the air, it forces the fluid, which is water, up. Just like we see in the astronauts when they're supposedly walking outside the ISS with the Earth underneath of them, we see bubbles float up. It's because they're filming it in a pool. You go down to the bottom of a pool. Has anybody ever told you that if you're a scuba diver, you can lose your orientation of up and down? How do you know what's up? Follow the bubbles. The bubbles will move up always. Why do they move up? Because it's moving from greater density to lesser density. It is a scientific necessity of fluids. A scientific necessity of fluids. It is a requirement of fluids. It has to move from more dense to less dense. Has to. And if you don't have something in the way to stop it, that's what's going to happen. Now, what if we had this situation here, where water, for whatever reason, was less dense than the air? This is exactly how it would be. And why do we have a lot less air? We don't have less, it's compressed. Air can be compressed. You can buy compressed air at Walmart to clean off your computer keyboard. Can you not? Air can be compressed. Water cannot be compressed. Water can be put under pressure, usually by air pressure behind it. But it cannot be compressed. Now, with that being said, if you had the situation where water was less dense than air, they're both fluids. If for some reason water was less dense than air and you had a water bubble stuck underneath the air without anything in its way, what would happen? It would rise until it got to where it needed to be equal, okay, with the density around it. So in that case, water would flow uphill. There's no two ways about it. It is a requirement of fluids. Requirement. This is no contradiction to science. None whatsoever. So if this was a river, and this is the facets of what we experienced where water was less dense than air, the water would flow uphill. Okay? So, likewise, water flows downhill. Let me see if I can pull that over here. Water flows downhill because it's moving from less density to more density until it gets to the point where it equalizes. If this is very cold water, it'll sink to the bottom. If it's warm water, it'll rise to the top. If it's in between, it'll get to the temperature that's equal around it. It must get to the point where it equalizes. If it doesn't, it will constantly move until it does. There is no exception to the rule. Friction is not great enough in this case to keep water from flowing uphill if you had more dense air below it. In fact, we could probably do an experiment where we had compressed air. Of course, people would say, well, it's something else that's causing it to move uphill. But if you had compressed air to make it more dense than water, I guarantee you the water would move uphill. Why do I guarantee that? Because it has to. It has to. It is a property of it. Now, because that defies what gravity says. That makes gravity, the way it is defined, as wrong. It is an improper way of describing how things happen on the earth. Yes, things do fall at 9.8 meters per second squared until they hit what? Terminal velocity. And then it doesn't accelerate anymore, does it? Why doesn't it accelerate anymore? Think about that. Anyway, I want to keep it at a first grade level. I'm trying to show you that water would be forced by the very principles and rules of nature to move uphill if something was more dense below it. Now, more dense than water is maple syrup. They showed that. If you put water, okay, and push it to the bottom of maple syrup, okay, the water then would be at the bottom. You will then watch, it'll form a bubble usually, or bubbles. Those bubbles will gradually move their way up through the molasses and back up to water. Because it's going from a more dense to a less dense fluid. And that's it. It's that simple. We will get what causes attraction to the earth, so to speak. It's not gravity. This shows it's not gravity. And I fully understand why balloons float and why aircraft carriers float. So that's it for this. Hopefully those of you who can have eyes and ears to see and hear, you get it. Take care, guys. Bye.